First of all, welcome everybody to my session, and I'm going to be talking about GenAI. And I do have to say that this is more for a session for more folks, who are wanting to learn more about GenAI. So it's less going into deep into certain areas, but it's an overview of generative AI. So hopefully, too, will help you. Especially, I'm sure some of you are experienced developers just wanting to get into GenAI. So if you're in that category, this is the right talk for you. And but if you find it not the right thing, don't worry. You're welcome to choose their other sessions too. So I won't be offended. Okay, so that's me. And let me first introduce myself. So, let me give you an agenda first. So first I'll tell you who I am, and then giving you brief background intro to GenAI, and then understand the players in this GenAI, this era. And then we'll explain to you all of these terminologies that are all being thrown everywhere these days. And then the RAG, and some of the more popular things that we have heard about, design pattern, vector database, and also like this multi-agentic collaboration thing that I'll also touch on. And then also wanting to bring to your attention the challenges of GenAI too. That's actually very important to know. And then we'll share with you some resources, and that should take up like the next 40 minutes or so. Okay, so first of all, who is Mary? I'm based in Chicago. I'm currently the AI practice lead for a company called Calibrity. That's a consulting firm that's traditionally been doing more enterprise development in Java, .NET, and DevOps and cloud, all these things. But about maybe 3-4 months ago, and they found out that they've been asked by a lot of customers and prospective customers asking about AI that they are interested in. And I'm sure you are too. That's why maybe have drawn you to come to this session. Probably you have heard of it or just interested to know more. And as such, that's how I got in to help them with this, being the practice lead. And at a consulting firm, I'm helping them not just like with, I don't get too much into hands-on coding, but it's more like the strategizing, also helping with customers to learn about GenAI, and also with the consulting projects and solutioning that aspects, and working with consultants as well. So maybe at some point too, I may be looking for help so stay in touch with me. I may have opportunities as well in the future. Okay, so the company is based in Cincinnati. It's a small firm of about 100 or so people. But before that too, I was actually a developer advocate, and first at IBM for 4 years as their Java developer advocate. And then I joined DataStax and helped them with Apache Pulsar streaming, event streaming, and also in the Java space. And then about a year ago when I was at DataStax, they wanted to switch basically to the company to repivot to being a GenAI. So then they added in vector search capability to their Apache Cassandra database, and also with their cloud Cassandra too, which is called Astra. So that's how I started working with GenAI, just to give you some idea. Plus, when I was at IBM too, I also worked a bit too with traditional AI and machine learning. So that's a bit of my background about the AI space. But otherwise too, I've been a developer too before becoming an advocate. I was about 20 years or so. First started working with C and Unix, and then switched to doing Java when Java came out. So mostly Java, open source, DevOps, those things, and that's what I worked on. So I understand too, especially if you are a developer for IT company, enterprise, I understand very well because I was also in those situation in those IT shops. For example, at Chicago Mercantile Exchange and Bank of America in town, US Cellular. So that's where I worked at too. So I come with a lot of passion too. That's kind of my area, my thing. I really like it. So I started helping with user community, and now I have been helping the Chicago Java Users Group since 2015. I'm currently the president of them, as well as running AI Camp too. If you're not familiar with it, AI Camp is a meetup group that also has a Chicago chapter. So I'm leading that chapter too. So I like to also invite you to join my user group. So that's about me. And then you can see too all the things I've been working with, all the Java, a lot of Java stuff, and then getting into AI. But my interests too have always been in distributed systems, and now actually with AI, I'm finding it fascinating because to me, AI is nothing all brand new, but it's just an aspect of computing that's a bit above just the traditional computing thing, as we all know. And it's really about artificial intelligence. So I find it interesting that it can actually help us in what we've been doing all along much faster, all of these things. So, okay, so that's me. And let me really start now. Brief introduction and background of GenAI. So let me kind of first start too with some history, right? As we all know, AI, machine learning are not brand new things. But I do have to say too, I think in the present form of AI, we can kind of trace back about 100 years ago or so in the 1930s when there were like a lot of science fiction came out that when people were asking about can machine think? And that actually came out from the father of modern computing, Alan Turing from the UK, right? He was very well known for being, leading this thought, like a thought leadership too. So since then too, like in the 20th century, as we have seen, there are lots of, interest into developing AI, and then there are also virtual reality too, if you are involved with that. Actually, that was something I also got in when I first became a software engineer in the 90s. And so that was interesting, but it's kind of earlier form of, so to speak, like AI stuff. And then I actually also played with in Emacs, if you use Emacs, the editor too, right? Some of you do. But they also have a doctor thing. I remember it was an early form of chat. It's not really GPT, as you know, but it's kind of leveraging on the AI concepts. So I've kind of played around with that back in the 90s kind of thing. Anyway, so as we can see, all of these are evolving really rapidly. And then I like to point out, because I worked for IBM before, there was Deep Blue that played chess. And that was also like a supervised training kind of dedicated machine to just play chess. And that Deep Blue came out in 1997 and beat Garry Kasparov, the chess king champion of that time. So that was kind of interesting. So all those things are kind of leading up to where we are today. And by the way, my slides I will be sharing with you, and then you can also get a hold of that slide and look at some of the links that I have in there too. So no need to copy down anything if you don't have. Okay, so first of all, about AI. What it is really about is that it's really about automation. Automation to the point of, I think ideally, would be having the machine figure things out to kind of have the intelligence of not just doing things, but maybe figuring out what needs to be done, all these things too. But we are really not there yet. And let's also kind of take a look too at how they are related to one another, right? All these terminologies, AI, machine learning, deep learning. AI is more like the umbrella term that basically it mimics the intelligence of human behavior, human thinking too. That's AI. And essentially too, if you go kind of think of it like an onion, right? That you can go in, then there's machine learning. Machine learning is the part where it's starting to give it power, in which we're kind of talking about, involving techniques for a computer to learn, not by us training it, but by them training based on the data we give it. So then that's kind of came out of all the terminologies like supervised training, unsupervised training, reinforcement learning. All of these are machine learning. And essentially, too, that's where we're also talking about models get trained in there. But just by machine learning, the techniques are not enough. And that's when we get deeper into the core, which is deep learning. And that involves what is called like neural networking and neural networks, right, of all the neurons that's mimicking how the brains work, right, how human brains work. And that's where all the current GenAI, all of the LLMs, all the computer vision, all of these things came out from, is really from the deep learning layer, that it can look at, processing the languages, the computer vision, all of these things is where it is. And so let's take a look then, fascinating look at this GenAI, kind of phenomenon, right? As we all know, it took the world by surprise back in November of 2022. It came out, and then because now you can actually talk to it in human language format. It's opposed to, like before, traditional computing is that you have to do everything kind of very rigidly. If you want to give input, you have to give it in a certain way, otherwise your machine won't understand, right? That was before. But now it's basically you can talk to it like you talk to another person. So as you can see too, even from the input side, right, when we've been trained as programmer, we're doing things like very, in some ways, kind of rigid too. I mean, it works, but the thing is to think of how the input used to be more rigid, because you need to kind of specify, maybe supply parameters to a program, and you need to tell it what it is, and then inside your code, you would have to convert all of your data into different data types, all of these things. And actually, basically, that's very time consuming, in my opinion. So now with AI, right, it takes away that kind of grunt work, so to speak. I mean, that's important too, but then based on just language input, kind of spoken language, and basically it uses like fuzzy logic to kind of take in all of your input. So that's kind of one big kind of advantages if you kind of think of like GenAI can help us too. So essentially too, what it does is that it helps the way how we generate all of the contents. As we all know already seeing, you can just talk to it and it comes up with some beautiful pictures, or give it a video, it will tell you who is in it. All of these things, right? The multimodal capability, and that's GenAI. And it uses machine learning as well as deep learning, neural networks to kind of achieve that too. And kind of look at the generative AI too. Another thing about it is that it tends to be more working with things on the creative side, because before GenAI was more predictive AI, which we've been actually doing for years too before this. And for predictive AI too, it often is dealing with business forecasts or weather forecasts, some kind of data and prediction that has a time limit to it for those kind of usages, right? But then for generative AI, it's a bit timeless, so to speak. It's dealing with creative things like writing an essays, designing a dress, and writing code, things like that. So we can think of GenAI kind of have a bit more of a timeless kind of capability to it too. Okay, so just really quickly too, right? When did it start, right? Generative AI. It started at around like the year 2000. And of course, we work for Google. As you can see, Google here too has done a lot of research too, but I just want to highlight a couple things. So in about 2003, there was a feed-forward neural network led by Yoshua Bengio as a language model. And then in 2011, that was Apple that brought Siri to the mass usages, right? Through Siri. It has, basically leveraged on natural language processing. And then 2013, the Google research that was leading this word-to-vec research, I wanted to highlight that because it forms the basis for doing vector database. All of the embeddings is actually stem from that research too. And it's also, it was a Google research project too. And then 2017, that was kind of that paper called the Transformer, also a Google project. And that was led by Ashish Vaswani. And that's where you've heard of the famous tagline, attention is all you need. That's where it came from that paper too. So that's kind of all the movement then is leading to where we are today, and it keeps going to this innovation. So first then look into generative AI. It relies on the model to help us to do things, as we know. And these are just a couple of models I thought I would share with you, just for those especially who are new to here. And there's from OpenAI, there's GPT 3.5, which actually shocked the world, or kind of brought the world kind of to a surprise. Everybody dropped what they're doing looking at it. It truly was kind of a big innovation at that time. To me, I think I compare it with like when when first the Wright brothers was able to fly their airplane. It was like that kind of a shocking moment, and nobody ever would have thought, some machine can fly in the sky back then. And now it's like, well, nobody would have thought you can have a machine that can understand human expressions and do things for you and come out with very amazing writing and essays, for example, things like that. So anyway, these are some of the generative models. And then OpenAI has also GPT-4 and GPT-4o, the most recent one that's kind of pretty advanced too. And then there are also of course, Google, there's Gemini, which is previously was called Bard. And then I'll point out too, there's also BERT. BERT came out too before this generative AI era. It's basically is more of a transformer. And somebody actually pointed out to me, it's not really quite an LLM model. I think if you kind of think of it like that, it's because BERT is dealing more with transformation and not as much, doesn't have the generative side to it too. So whereas for Gemini is a multimodal kind of very powerful model, as we all know, that came out earlier this year too. Okay, and then there are other ones like Stable Diffusion is the first image to text model that came out that led to like innovations like DALL-E, Midjourney, all of these things. And then there's also from Meta, Llama 2, Llama 3, these are open source models. And I've heard good words. People actually tend to like Llama. And I have to say, I have to kind of admit, I haven't worked enough to kind of give good comparison, but I've ran into a Red Hat person 2 weeks ago in Boston at the conference. He said, I think Llama 3 is still the best, and he feels it's open source and it's quite efficient too. So that's his thing. So yeah. Okay, anyway, so, okay, and then there are also other ones too, like Mistral has their 7B, that seems to be very popular, open source one, and Cohere also has their command, the lines of models, and then Anthropic has Claude, and Anthropic actually is sort of a branch off from OpenAI too. And then there are also Whisper, that's more audio too, as you're aware, and then Codex, which is the model behind GitHub Copilot, so. Okay, so this is just a small little slide, but probably you shouldn't even be showing it. Now I think of it, when I first got this, I thought it would be good to show some generative apps, right? These are just apps like ChatGPT is an app that makes use of GPT, that model. GitHub Copilot, right? And then the rest, there are just so many apps out there right now. Salesforce, SEO. Gemini itself also is a generative app too. It has its own platform as well that also makes use of Vertex AI. That's kind of from Google too. So those are that. Okay, so now wanting to point out too about like modality. As I mentioned about Gemini is a multimodal model, which means that it kind of supports different format, right? There's text. These are like essentially the 6 main format: text, image, code, audio, video, and three-dimensional type of model. And basically too, actually, I should say about a year ago when I started working with GenAI, I realized that the modality, the interchangeability wasn't as good. But today, a year later, as we can see, there are a lot more models that come out that can kind of do that quite well. But of course, research is still ongoing. And then Gemini is a very good example of a multimodal model too. So, and then of course, there are text to image, and you can do audio to video. OpenAI has the Sora that came out that can do text to video, which is actually quite impressive too. I've looked at it. So, okay, so that's that. Okay, so here we go. We talk about the model, large language model, right? But we want to actually be able to step things up because we're enough of being wowed by this, phenomenon of amazing model, all of these that can write an essay, design a dress, all of these things. But if you kind of think deeper, actually, as much as it is powerful, but the thing is, if you kind of think of, you go to chatgpt.com, ask some question on that interface, and then you ask, and then it essentially cannot keep track of, your whole context too. If you don't do anything extra to it, if you don't write some code and keep that. So in other words, right, LLM itself is kind of just a giant chunk of kind of capability of answering a lot of questions, not everything. As we all know, for example, ChatGPT 3.5 only has data up to like 2021 because it came out in 2022. So basically, it has a limit to what it can have. And then if you need to train LLM, as we all know, is very expensive. It takes days, kind of to do it too. It's not a simple thing. And as we can tell, it's not sustainable at all. If we kind of take into account all the energy it has to do. And for example, I heard too, there's a comparison that says, if you do a Google search on some things and then you try to do the same using ChatGPT to do it, and basically it takes 10 times the amount of energy to produce the answer than you would have if you use traditional old-fashioned search. So then, while it is exciting and everything, but we really need to start to think of, it's not sustainable, it's gonna take so much energy and it generates a lot of carbon too. It's something that we may not even be thinking of sometimes, right? The data center is all the energy you need to cool it, to power it, all of these things. So that's an important aspect. We do need to think about it. Eventually, I think there are already a lot of research being done. I think NVIDIA, I understand they are here too, and NVIDIA also having chips that are a lot more efficient, which is a very good sign. So, okay, so LLM limitations, right? It doesn't have memory, and also the results are probabilistic, and they also very opaque. You can't really add any attributes to the responses you get back, right? The costs and everything. And not only that, right? We're kind of more used to doing, if you're just doing the regular dialogue and doing this one-shot type of query, just ask a question and you actually don't give it more chances to, let's say, rethink and regenerate answers to you, and that's all it can do. It's more like zero-shot or one-shot type of usages, right? So if we are going to leverage on generative AI to make it more useful to, let's say, we want to write an app to handle airline flight reservation, right? So it takes a lot more steps to it, and how can we do, right? Also the scalability issue, memory, all of these things, we need to kind of start thinking about that too. And it's basically the hype is gone, then we need to start thinking seriously. So there will be kind of ways of doing it too. However, if you look at it again, this GenAI evolution is still quite good, kind of depart itself from the traditional AI kind of way of doing things. As we all know, for machine learning, the general two phases is, the first phase is doing training. You train the model, and then you go, when its model is ready, and then you go and what we call inference phase, in which you are leveraging on the model, you're using the model to look for answers that you want, for example. So now with GPT, with this approach, basically too, we're training, and there's LLM, it's right there, and then you can apply prompts, essentially, right, to prompt it, and then you apply it to the model and get the answers you want. And I think this approach is still kind of, helps in terms of giving access to people to try to use it. As we can see already, you can go to chatgpt.com and use it, and different kind of models you can actually, have interface and use it too. So it's still a good thing, but it's just that there are a lot more work that needs to be done to make it really production ready. Okay, so now, having a bit of an understanding of this GenAI, the model of these things. So let's take a look too at the players in this GenAI era too. Now, there have been a lot of people that kind of talk about, well, it's going to take away the jobs. And I really don't think so, because there actually will be new jobs that are available. I mean, first and foremost, we already look at their prompt engineers that are coming out and doing prompts, and which never existed before. So just an example. And to me, I also believe there will be need for more people helping to do audits too, because it's not really trustworthy yet. So how do you know it's generating very good results that is accurate, right? Those kind of things. So anyway, let's also then take a look at the players. But first of all, in this era, we have these GPT. So it stands for Generative Pre-trained Transformer. So its job is to take, simple prompts in human language format, and then does all the pattern matching inside of it, and then is what is called like similarity searches, and then it answers questions for the prompts, and it produces contents like an essay, as I talk about, right, writing a blog post, and it's quite good, and if you are in a writing profession, I think you'll find it useful to help you to write, to produce some of your writing contents too. It's kind of assist you to doing that. So that's GPT. And then, just a very quick kind of point out too, as far as GPT is concerned, it came out in about back in 2018, so quite new. And that was when OpenAI first came out with the first paper for GPT. And then immediately, 2019, it came out with GPT-2 with a larger data sets too. And since then too, we have seen it actually moving faster and faster, and there are many more companies that are developing similar kind of language model to do the kind of generative AI work too. And then here too, it's just a repeat. I already showed there's Stable Diffusion had their first image to text and text to image model. That was back only 2 years ago, like 2022 as well. And then of course, GPT 3.5 came out in November of 2022 and wowed the world and reached 1 million users within 5 days. Okay, so now let's also then take a look too into the NLP, right? It is actually the crux of what it makes the GenAI kind of this technology possible. Is kind of is important. It is what it is that it's really interdisciplinary subfield of linguistics of computer science too. For example, there are also like subcomponents too. And I was the other day looking into, for example, we can use cases for GenAI. I think to me, you can think of like if you are doing testing, right? I'm sure if you're especially large banks and you want to be able to use some data that's in real life and be able to use it for your testing, right? Before releasing your software systems. And because the test data, very often it contains sensitive materials, secure data that you cannot expose. So you want to have techniques to try to mask it or de-identify some of these things. So one of the techniques you can use is kind of a subcomponent of this NLP is called NER, like named entity recognition, that you can also use that too. So that's kind of a subfield that coming out of this NLP, there are many subfield components that can help you to kind of use languages to do what you need to be doing. So that was an example, NER, for data de-identification. So things like that. So, okay, so that's NLP. And it's essentially, too, it helps computer to learn from the contents, right, based on these languages in human spoken format, too. And then the idea is that, from these languages, you want to mimic like human beings. We listen to languages, we process it, and comes out, you think about it, and you come out with some relevant answers. So that's NLP. And NLP is actually, that's what is used by large language models, too. And as we know, right, LLMs are like everywhere. Because as developers, especially, I'm assuming most of us here are developers are working, developing. So that's what we interact with, right? The models is what encapsulate all of these data in it. There are tokens and parameters that you have heard of. Tokens are essentially the smallest unit of the language that it gets broken down. Let's say you have a string that comes in, like a string of things, it usually breaks them down into tokens, and they are just essentially the number of words, let's say in a string, for example. And then there are parameters that are being used to tune to tune how you build your model too. So those are like large language models. And as we all know, that's foundation type of model that's trained on a broad range of data too. And as we can see, right now, ChatGPT, all these things, and GPT, they would be training on some general data and its general purpose. But let's say, right, I work for a company, I'm a legal firm, or health, especially with hospital and all these, right? And you want to maybe consider also train your own sets of model of LLMs for your own private use, because you have certain kind of sensitive data too. So you can also kind of think of it training your own too. But the thing is, so to kind of remember, as I mentioned earlier too, is that it's very expensive and it takes a lot of GPUs. Even with a lot of GPUs, they cost a lot of money, right? And you need a lot of them. And then even with them, it will take a lot of time to train them, as you can see, right? They can, like essentially human language, we can have so many different combinations. So you can imagine this model will have to learn the many, many different combinations of the use of these tokens, and do they make sense of these things? Even within a word, you need to break them apart and identify things like that. So, okay, so then we can kind of look at it, an LLM is basically too, it not only can it process languages, it also does visual comprehension too, and also generate code too in today's model too. But the one aspect of it is basically dealing with like very human-centered engagement too. And that's kind of very different than traditional computing, in which you're just giving it, asking it to compute, let's say based on some formula to generate some numbers. In this case, you are talking to it like a person, and it will come back and also give you a rich context too. And that's what LLMs are very capable of doing too. Okay, so now then, remember that set the diagram, AI, ML, and deep learning. Now, if we kind of expand it further, you can see where the LLM sits, right? It's basically inside the deep learning part. And essentially, that's where the GenAI, all of these transformers kind of sit at, is in this deep learning space that it is. And there are LLMs dealing with transformers of all the languages, and there are images gen that has the GAN and the VEI type of transformers as well. And then as you can see too, it also, LLM makes use of natural language NLP, processing NLP, and also like a lot of data too. So that's what it is. And this diagram, by the way, is taken from Google Cloud. I found it to be very nicely explained, like what, how they all relate to one another. Okay. Okay, so now then, as developers too, we also may be wondering then, how can I work with LLMs, right? Obviously, we need some sort of APIs and things like that. And if you are not already working with it, then there's a very popular library that's still relatively new, came out, I think, in 2023, so a year ago. And LangChain is I think by far one of the most popular ones. And also it has a lot of subcomponents coming out of it. I think there are LangSmith for doing DevOps type of thing, and there are LangGraph. I think there are also also from there too. LangChain is no doubt one of the more popular ones, and it's primarily in Python, also has JavaScript or TypeScript type of capability. And then there's also Llama Index too, that's also seemed to be quite popular as well and very capable. It's dealing more with the text processing side. And then there's also from Microsoft, there's a semantic kernel. That's open source too. And then Gemini API, that's from Google, and that allows you to work with the Vertex AI from Google as well. And then there's also Hugging Face, which is, think of it like a repository for all of the GenAI AI type of resources that you will need, and you can share in there your models, your data sets, and even I think there are playgrounds as well, so you can work with them there. Kind of, to me, it's like a GitHub, sort of like GitHub, but for specific like AI machine learning resources. Okay, so now because I work with Java, for those of you, maybe if you work with Java, I'd like to point out then Java is not falling behind too much in the AI space. I mean, it's kind of falling behind, you have to say. But the thing is, too, there's also LangChain 4j, which is the Java implementation that kind of mimics the LangChain. There's a different group of people working on it, too. And then Semantic Kernel actually also has a Java SDK. And also, if you're a Spring person, there's Spring AI that recently came out, too, that also integrates quite well, or at least they have good integration with LangChain 4j. And then also want to point out there's JLlama, which is kind of more a Java port kind of working with Llama too. And it's actually my ex-colleague who's the architect at DataStax, and he developed a JLlama for it. And then also there's a lower level library called JVector that's basically help with like vector to improve like vector data searches for data store type of searches too. And then there's also Llama 2, which is a port of Llama C. So that's just some additional information for you. And this one I probably won't spend too much time. It's just how do you do it in LangChain 4j. This one, because this isn't a Java's case, so I won't kind of share with it here, but you can look up the information too. Okay, so in terms of human or kind of players in this field, right, then what about the people players, right? And we still have all of our data scientists and computer vision specialists. They are specializing in what the data should do. They are really subject matter expert, but very often too, you find them, they may not be coders or developers. So from a developer side, we have data engineers and a new type of role, which is AI engineer, in which you're a developer, but you are familiar with how AI should work, and we work closely with data scientists to develop the code. And there are also ML ops engineer. That's basically, and to me, it's like an extension of DevOps, but you are improving the process, right, of doing machine learning type of applications. So to me, I don't think there will be fear of losing our jobs. In fact, I think there will be new jobs that will kind of come up that will help in this developing this technology too. Okay, so now let me then get into a couple of the, more popular kind of, technology or kind of a pattern, right, that comes out of this GenAI revolution, right? And first, there's retrieval augmented generation, the RAG, and that seems to have become kind of everywhere you see technology, kind of a paper or, industry like articles, they all talk about RAG like that. So if you're not familiar, it stands for retrieval augmented generation. So as I mentioned earlier, LLMs are very limited too. Let's say, I have ChatGPT 3.5. It has actually trained on data only up to 2021. So let's say if you want to use ChatGPT 3.5, then what do? You need all the data that's more up to date that would make sense, right? You don't want to just be querying old data. So the thing is, you can use these techniques. It's more of an architectural pattern. It doesn't dictate how you do it. So you can be writing a RAG that's essentially following these guidelines, this principle, the concepts. It's basically a hybrid framework that integrates like two components. So the two components is, one is a retrieval model, and the other is the generative model. So let's kind of take a look too. So the role of a retrieval model, so in a nutshell, is what it does is it's like a librarian. The retrieval will be going there and collect all of the data that's kind of outside of this LLM. So it can actually, you can be writing a code that you actually have data. Let's say you are, private IT shop, you're doing specific processing for operations in your company, and then you need to look up data from your database, which has more of the up-to-date data. So you can basically basically have, a data source from your private database that get fed into this retrieval side of things so that you can get the latest data. And not only with database, you can actually, if you're, let's say you have like messaging systems that are running, let's say Kafka, some kind of streaming thing, you can also actually have a Kafka topic, for example, that you can actually draw data from too, right? And also too, unstructured data, you can feed them in, like, let's say you are a human resources firm or what you call a recruiting firm, then you have a lot of, resumes, for example, you can feed those in unstructured kind of data too. So all kinds, you can kind of use retrieval model to retrieve this kind of data that won't be in your LLM. And so now with all these information, then, after you feed them in, you can actually then use it to feed it over to the generative side. So as such, generative model is like a writer. So it takes all of these things, and of course too, essentially too, you retrieve it, and then you also prompt your question, and then feed them to the LLM for your final selection of your query, right, to the LLM. And LLM will come back with the data. So basically, the generative model will then take this data and create the beautified text for you. Let's say if it's a text generation, and it will check that is grammatically correct and everything. So generative side is essentially a writer. It's not only writing what is needed, it's actually will extend it and make the context even richer. Essentially making your information, it will enrich it for you too at the end. So they both kind of work hand in hand, this RAG model. Essentially, that's what it is. And you can kind of develop your own RAG model or use whatever it is. I'm seeing a lot of like RAG kind of systems or libraries that are popping up every day. So you can kind of look into those too. So that's an important technique for this, for the usage in here. And now let's also then take into vector, or kind of look into vector database, and similarity search. So what is vector database, right? It is a purpose-built database that serves up vector data type. So you might be wondering, well, can't I use like traditional normal database, let's say Postgres or something? Oh, you can use it too. However, it probably will take you a lot of time if you try to store the data the way you want to be used, in a generative AI type of apps. The reason is that GenAI apps, right, we're kind of now looking into data in new ways. We're kind of looking at like being able to handle data that's multidimensional, because we're looking at the data, not just the data itself, there are different dimensions of these data. So in order to be able to store them the way that we need them, right, to be interpreted as, then you need new way of storing them. And so that's when vector database, vector data type comes in. And then there's also this terminology called vector embeddings, because in order to be able to store your data in a multidimensional format, you need to convert them into a way that it can be stored and then can be searched efficiently and then also return it back to you. So that's what is embedding is essentially is that if you're looking at a database, you need to store the data, so it will need to be converted into vector data type, and you need to rely on an embedding model. So currently too, there are a number of embedding models, and from OpenAI, for example, that you can use for. So if you want to store them into a database and make sure that you use a model, the same model that you store them, embedding model, store them into the database and use the same model to query it when you are searching for information too. And essentially embeddings are just numerical representation of your data. So if you kind of do a select on some database, right, it comes back actually an array, you see arrays of floating point numbers that unless you are really a number person, you probably won't understand just by looking at these long lines of data, because that represents the different tokens that you can have too. They are essentially, again, arrays of floating point numbers in there. So think of it like that, right? And it's also like in machine learning terms, it's also what is called feature engineering. It helps with that as well. And then the techniques you can use, is called approximate nearest neighbor or some form of nearest neighbor. Because in order to now, you want to do searches, and guess what? And if you're a math person and if you have taken linear algebra, then you probably understand this right away. This is really essentially matrix math, right? So this is a very simple example of how you can think of vector database, how it does searches. In this very simple example, we'll use only a two-dimensional vector to express. So let's say, you have V1 in there, that's the search query vector that gets translated from some data translated to V1, and it's represented, as an arrow up there on the two-dimensional space. And then what's been stored, there's V2 and V3. So when you go and do its searches, the algorithms will come back actually giving you the answers of closest neighbor will be V2 in this case. So this is just a theoretical and, again, very simple case. In reality, you can have, many dimensional data too. But this is an example too. Let's say, the search string is a cat, and then you can look around. There's closest to it in this particular case will be a dog and a house for you to choose from. It will naturally be a dog, because how it gets placed in that two-dimensional space is based on all the interpretation that gets translated, from based on the embedding model. And the dog is actually closer to cat too. So that's why the dog will get retrieved. And also a note to point out to a lot of the vector database, when you do searches too, you can also specify how close do you want the answers to be. It can be like, I wanted like 5%, deviation or something like that, right? Then it depends on how close do you want the answers for. It will return the set of data that's within that range that you have specified it for. So that's essentially how I can explain vector database in a quick kind of few minutes, right? That's what it is. And also too, then you'll be wondering, then how does it do like multi-dimensional, very complex kind of searches? In this case, it actually makes use of, if you're a math person, it gets into all the different layers as well too. So this is just a kind of visually explain to you that we can have different like layers that represent the different dimensional data of all that you need to be searching for, and it uses like vector math to kind of calculate and return you the answers too. Okay, so I think I've only not as much time left, but I'll just quickly give you some examples. There's a vector. These are just some of the vector database if you're looking into it. And also, too, the good thing about if you consider using it is also because you need somewhere to store your data, too. So you can consider using vector database. There's Milfus. PG Vector is an extension of Postgres. Chroma and FAST is from Meta. And then Quadrant and Weaviate. These are kind of quite popular open source database that has vector capability. Okay, so these are just different like usages of vector embeddings too. So besides like using it for similarity searches, you can use for clustering, recommendations, for example, and anomaly detection, diversity measurement, and what is called classification and machine learning type of kind of usages too. Okay, so I already explained, we know that traditional database has its limitations too in handling multidimensional data, so you may want to consider a vector database in that case. And this is just an example of a RAG application, how you can kind of think of it like how vector database can kind of blend into this picture of you working with LLMs and then their data that floats in between, and you can use, the different embedding, like basically convert your data into embeddings and store them into the vector database for different kinds of usages within your RAG app. Okay, so now the last part of this conversation is really about agents and workflow. I just want to add a word to it too. I know I talk about a lot of terminologies, but this part too, I'm kind of excited about. It came out, this idea of multi-agentic workflow is actually quite recent that came out, right? Maybe earlier this year. And I started reading up about it a little more too. The reason is that if you kind of look at LLM, again, it is fascinating, but can it move to the next step to do airline reservation, for example, complex workflow. So we believe, a lot of industry experts too do believe, right, that this agentic use of agents can actually be helping. Why? Because if you think of, we live in a complex world that are, the data, think of, in a system as the data is flowing, but even like in human beings, how we interact with one another. Just think of even your projects at work too. In the projects that you work with, especially at an enterprise level, you need project manager, you need software engineer, you need QA people, you need product DevOps people. So you kind of can think of agents more like they each have their own distinctive responsibility. Some may be doing only this one single task, and that's all it does well. So in order, you want to be able to do complex workflow, you actually need an agent that oversees it and being able to orchestrate it. So think of it more like an orchestrator type of functionality. So that's where I think the agents can come into play and to help us to develop complex workflow. And So it is, the key is that being able to orchestrate and coordinate with multiple different agents, making sure everything will all occur, like your flow, let's say a workflow can occur in the right sequence, things like that. So that's where it can help a lot too. Now, in the case of like AI, generative AI kind of context too, there are these design patterns that you can think of, right? Essentially too, one is reflection. So think of the fact that you're now you used to be asking LLM, ask a question, and then it comes out with some answer. But now with the agentic way, you can kind of do things that will essentially to have the questions, or actually have the LLMs reevaluate itself, constantly refining its answers. So that's reflection. So let's say I'm asking the LLM some questions and comes back with some answer, and I use that answer to feed it back to the LLM and said that it isn't quite a good answer. Can you look at what, how you can improve it? So it's a way of doing reflection. You're asking the LLM to keep evaluating itself and to refine the answers for you. So that's a reflection. It's one of the design patterns that you can use in an agentic flow. And then there's also tool use. Tool use is essentially you are giving additional information for your LLM. Let's say my agents can be set up, so then we will kind of prompt the LLM and said that I'm asking you this question. If you cannot find answers, I'm going to suggest using Wikipedia to use some URL. You can go and look at another web page to look for the answer. So you're kind of helping the LLM with some additional help to using this tool use kind of pattern. And then there's also planning. Planning is a little bit trickier. It's a more abstract concept too, as I'm reading it, is that basically you are asking the agent to also plan out all the steps to figure out an answer. So it's a little bit more abstract, and also you are asking the LLM to become smarter in itself to figure out the steps for you. And it's a bit newer to that concept. And then of course there's also multi-agent collaboration, and that's important. It's basically, as you can see, doing any kind of complex workflow, we're going to need many agents doing different things. And in that case, you will need someone to be there to oversee and making sure all of the agents are performing their job accordingly, and then you can collect all of the answers one way or the other. Make sure the final answers come back correct is what it is. It's the multi-agent collaboration kind of concept in there. Okay, so now just very quickly to share with you a couple of multi-agentic libraries. They're AutoGen, and this one's from Microsoft, and then CrewAI, and also LangGraph is from the LangChain, and then also AutoGPT. I've used a little bit, I look into AutoGPT. It's kind of more rigid. I think there's a general block, that's what it's called. It's a bit less kind of flexible in my opinion. But then there are also many other agentic libraries. These are mostly all in Python currently. So. Okay, so I think I have probably time's up, but want to really quickly point out too that GenAI is exciting, but as exciting as it is, there are challenges. As we all know, hallucinations, right? We know LLMs don't always know the answers, and sometimes in some cases, it will come back with a lot of times, I think, also come up with wrong answers. So be aware of that. And also ethical concerns too, that maybe when we're asking the LLM for some questions, it can come back, with something that's not right. For example, I was actually talking with another ex-colleague of mine who was saying that someone was asking, kind of ChatGPT or whatever model it was using, was describing that, oh, I'm so depressed, I'm not happy, things are not going right, family is not good, the wife is not listening to me, all these things. And then it said, what should I do? And the LLM came back and said, go jump off a bridge, right? So yeah, so that kind of stuff, right? So we have to be very careful. It can happen, it can tell you wrong thing, and it just doesn't have the knowledge of being, make the right moral judgment. So be very careful with that. Okay, and then there are also, how about real-time up-to-date data? So like RAG pattern probably can come in and help with filling in all these up-to-date data that you need. And then also, again, LLM usages, they're not ready for production, right? There's scalability problem, security concern, all of these are still there. The world government is still trying to figure out how to regulate it. Now, one more thing is, again, the sustainability issue. We know that it's actually, using GenAI is very expensive. The data center will actually have to work harder, right? All of these, you train your data, doing all the searches, is actually currently, they're still using up a lot of energy, producing a lot of carbon in the air that we usually don't think of. So eco-unfriendly. and an energy hog. So those things I think are being addressed as we speak, but still they're not coming up as fast as the innovation that's happening. But we do need to pay attention to that because we want to be responsible so that our future generations don't have to suffer from what the mistakes that we have made. And like maybe we are already suffering from what our previous generations have created for us, but we try to not to create as many problems. So, and with that, I'm kind of coming to a close. Want to share with you the resources. If you're interested, this is the slide deck that you can get a hold of, and I'll share. I have already shared it with the organizers too, just in case you don't have access. Please connect with the organizers too. And then here too, just a couple of starter labs suggestions too, because I did a workshop on PG Vector. Actually, I keep them here. I found them to be quite useful for vector database users. Okay. Make sure I don't, okay, somebody's still taking picture. Okay, all right, I'm gonna move forwards. And there's also Java. If you're a Java person, there's some hands-on lab, but you can actually go to LangChain 4J and look for the examples lab too. They have a couple of pretty good ones too. Okay, and then just some open source ranking information for vector database search engine too that I've found. There are also other kind of ranking too. And then I also actually have a stream. Today I don't have time to do some quick demo, but I plan to actually restart my stream on Twitch too. So if you want to follow me, that's my Twitch stream. And also I multi-stream to YouTube. And also, just one quick thing, I work for the company called Calibrity, but if you are looking, let's say if you're starting up and you want some idea, how to do something, we're into solutioning to helping you. So please contact me or also like join this program. It's called Lean Product Discovery that you can join it too. And then we'll be happy to help you to develop your project too and help you figure things out. So for free for 6 weeks. And with that comes to a close. And this is how you can stay in touch with me, my LinkedIn, my Twitter, X links, and I also have a Discord server. I have links to my Chicago Java users group, and please join us if you're a Java, especially if you're interested in Java or you're already doing Java. And also, I'm leading the AI camp in Chicago too. So please stay connected and share with me your stories too. So with that, thank you very much. I think I've gone over time a little bit, so thank you so much. Yeah.